In this video, we're going to be talking about factoring trinomials, but in these trinomials, your a, or the number in front of x, is not going to be just 1. In these examples, your a is going to be something other than 1. So, talking about the steps, the very first thing we need to do is look and see, does it have a GCF? If it does have a GCF, we can factor that out. And sometimes when we factor that out, we'll end up with a trinomial that has an a that equals 1. Sometimes we won't. Sometimes it'll just make it easier to factor. Then we're going to take the coefficient of the x squared term, or the a. We're going to take that a and we're going to take c and we're going to multiply them together. Whatever a times c is, we're going to look at that number, and then we're going to look for factors that multiply to be whatever that question mark in this case is, but add to be b. Kind of like when we were factoring trinomials where a was 1. It's kind of the same, but it's a little different. Then, when we get to step 3, we are going to rewrite our polynomial. Our first and our last term we're just going to bring down. The middle term that we had, so like in this case our b, we're going to take that out, replace it with the two numbers we found that multiply to be whatever the question mark is in this case, and add to be whatever b is in this case. Then, once you do that, you'll have 4 terms, and then our grouping comes into play. So, let's see how this actually plays out. So, we're going to start with example 1. First, I am looking and I see coefficient-wise, I have a 2, a 5, and a 3. I can't divide anything that's there. I can't divide variables because not all 3 have the same variable. So I can say that my common factor, or my greatest common factor, is just 1. But if I were to divide all of this by 1, it would stay the same. That means I don't need to factor out that 1. I don't need to change it. It's just going to stay the same. So I look for my GCF. Now I'm going to take the number in front of x squared and the constant, so in this case 2 and 3, multiply them together. Well, 2 times 3 is 6. Now I need to look for 2 factors of 6. So remember, if you don't know all your factors, you can start listing them out, start dividing. I know 1 and 6 and 2 and 3. If I multiply those, I get 6. So I'm looking at which of these sets of factors, if I added them together, I would get 5. Well, if I add 1 and 6 together, I will not get 5. But if I add 2 and 3, I will get 5. So because I now have my 2 factors, I'm going to rewrite my equation, or my polynomial. The first and the last term are going to stay the same. I'm not changing them, so 2x squared and 3. I am going to change my inside terms. I'm going to change that 5x to the 2 factors I just found. Because the 2 and the 3 were my coefficients, or are going to be my coefficients, and my middle term had an x, I need to include x in this. So think about it like you split that middle term into 2 terms. If I were to combine like terms, I would get 5x back again. From there, I have 4 terms, and I can start my grouping process. On the left, I can factor out a 2 and an x. Remember that when you factor out, you're dividing. So if I divide 2x squared by 2x, I'm left with just x. If I divide 2x by 2x, I'm left with just 1. On the right side, I see that I can divide out a 3, or my GCF on this side is positive 3. If I divide both of these by 3, I'm left with just x and plus 1. Remember that when you are factoring this way, your insides need to be the same. And in this case, they are. If your insides are the same, that becomes one of your factors, and everything on the outside becomes your second factor. So the two factors that multiply to be that polynomial are x plus 1 and 2x plus 3. I can double check this just to make sure this works by multiplying it back out. X times 2x is 2x squared. X times 3 is 3x. 1 times 2x is positive 2x. 1 times 3 is 3. If I combine my like terms, I end up with 2x squared plus 5x plus 3, which was the original. So this works. Moving on to example 2, same process. I'm looking for a GCF. I cannot divide these by 5 or 17 or 6 or any factors of those 3. My GCF in this case is 1. So that means I don't need to change anything. I'm going to bring my first and my last term down. Oh, I skipped a step, sorry. I need to multiply 5 and 6, which gives me 30. I'm looking for two factors that multiply to be 30, but add or subtract to be negative 17. So you may want to list out your factors. I have 1 and 30, 2 and 15, and I'm going to stop there. If I were to add 2 and 15, I would get positive 17. But if I were to make them both negative, negative 2, negative 15, that would give me negative 17. And if I multiply those back out, negative 2 times negative 15 is positive 30. So that still works. So I'm going to change my middle term, that negative 17m, to negative 2m and negative 15m. Now, the order in which you put these two in the middle does not matter, but I see that there's a 15 and we have a 5, so I want that 15 near the 5. But it doesn't matter. It would have worked itself out the same way if we did it the other way. And I'll show that here in a second. Then we can start our grouping process. On the left, I can factor out a 5 and an m. And I'm dividing. So when I divide each of these terms by 5m, I'm left with m minus 3. On the right, I can factor out a 2, and because the third term is negative, I'm going to factor out a negative 2, leaving this side with m minus 3. The insides are the same, so that's going to be one of the factors. The outside factor would be 5m minus 2. Just to show you that the other way would also work, we're going to go back to that first line, 5m squared minus 15, I'm sorry, I wanted to switch them. Minus 2m minus 15m plus 6. So in this case, it is switched, and I'm going to show you it still works, even though they're switched. On the left, the only thing I can factor out of the left is m. If I divide both of those terms by m, I'm left with 5m minus 2. On the right, I can't divide both of them by 6, but I can divide both of them by 3, and because the third term is negative, I'm making it negative 3. If I divide both of those by negative 3, I'm left with 5m minus 2. We have the same insides. Notice that they've switched from the first time we did it, but they are still the same. And if I were to multiply this back out, 5m times m is 5m squared. 5m times negative 3 is negative 15m. Negative 2 times m is negative 2m. Negative 2 times negative 3 is positive 6. If I combine my like terms, I'm left with 5m squared minus 17m plus 6, which is what the original was. So that works, even though I switched it. Right. Going back to example 3, same process. I'm looking for a GCF. If the middle term was a 4 or a 6 or anything even instead of a 5, my GCF could have been 2, but in this case I do not have a GCF other than 1, which means this will not change. I'm going to multiply 6 and negative 4. And I'm looking for factors of negative 24 that multiply to be negative 24, but add or subtract to be negative 5. It's negative 24, so one of them has to be negative, but I'm just going to write them all out first. And as you keep doing this, you may not need the factor tree, or you may be able to see it right away, or know what the two numbers are right away. If I have negative 3 and positive 8, that would give me a positive 5. But if I make 8 negative, that would give me a negative 5, which is what I need. So my two factors are going to be 3 and negative 8. So I'm going to bring my first and last term down. Plus 3y minus 8y. And then start my grouping. I can take out or factor out a 3 and a y on the left. If I divide both of those, I'm left with 2y plus 1. On the right, I can divide out a 4, and because the third term is negative, I'm going to make that negative 4. If I divide both of those, I'm left with positive 2y plus 1. And then I'd have 2y plus 1 as one of my factors, and 3y minus 4 as one of my factors. Let's try example 4. I'm looking at all of them, and I don't see a common factor that I could divide out of each of them, except for 1. So it's going to stay the same. I'm going to multiply 12 and negative 5 to get negative 60, and I'm looking for two factors of negative 60 that add to be 11. So I'm going to make another factor tree, 1 and 60, 2 and 30, 3 and 20. So far, none of these are going to add or subtract to be 11. 4 and 15, though, if I subtract 4, and add 15, that would definitely give me a negative 60 and a positive 11, if I multiply them to be negative 60 and add or subtract them to be 11. I'm going to bring my first and my last term down and use those two factors, negative 4c plus 15c, and start my grouping process. Once you get the hang of this, it's really the same process just over and over and over again. On the left, I can factor out a 4 and a c. If I divide both of these, I'm left with 3c minus 1. On the right, I can factor out a 5, and it's positive because the third term is positive. If I divide both of those, I'm left with 3c minus 1. So my two factors are 3c minus 1 and 4c plus 5. In all of these examples, our GCF was 1. Now we're going to do a couple examples where the GCF is not 1. I'm going to skip down to number 10, and then we'll do 11. So for number 10, I'm looking at it and I see that I could divide each of these by 2. If I divided each of these by 2, I'd be left with 10n squared minus 26n minus 12. Well, I can divide that by 2 again, which means I really could have divided all of these by 4. And to kind of eliminate that process, you could make a factor tree of all 3. And 4 would have been the greatest common factor in all 3. So if I divide each of these by 4, I'm left with 5n squared minus 13n minus 6, which makes it a little bit easier to deal with. So then I can start my process. Look for 5 times 6, or negative 6, which is negative 30. So two factors that multiply to be negative 30, but add or subtract to be negative 13. As you start thinking of factors, you may automatically think 10 and 3. If I add 10 and 3, I get positive 13. If I subtract 10 and 3, so they're both negative, I get negative 13. But if I multiply two negatives, I end up with a positive. And my answer needs to be negative. So 10 and 3 would not work, but 15 and 2 would if I make 15 negative. Negative 15 plus 2 is negative 13, and negative 15 times 2 is negative 30, so that works. As you are writing this down, because we factored out a number at the beginning, we have to continue to bring that number down every single time we do something else. So the 4 stays on the outside. I'm now bringing down my first and last terms and the two factors I found. Then I can start my grouping process. The 4 I factored out at the beginning stays. I can divide, or my GCF on the left is 5n. Leaving me with n minus 3. My GCF on the right is 2, and it's positive, leaving me with n minus 3. So my final answer would be 4 times the factor 5n plus 2 and the factor n minus 3. Or you could just use one set of parentheses instead of two, it would work out the same. To double check it, you could do a couple different things. You can multiply the 4 to the first factor, and then multiply that factor to the next one, to the next binomial. You can multiply the binomials together, and then multiply all of that by 4. Or, because multiplication is commutative, I could multiply the 4 to the second factor, and then multiply that to the first factor. Doesn't matter, but you should check to see that it works. I'm not going to do that in this video, but you should. For number 11, I'm looking at all of these terms, and I see that I can't divide each of these by 10, but I can divide each of these by 5. If I divide each of these by 5, that would leave me with 2k squared plus 15k plus 7. And then my steps begin again. 2 times 7 is 14. 2 factors that would add to be 15 that I can think of off the top of my head are 14 and 1. So I'm going to bring down my 5, bring down my first and my last term, and bring down my 2 new factors, and start my grouping process. Bring down my 5. Of the left side, I can factor out a 2 and a k, leaving me with k plus 7. On the right, there aren't any numbers or variables I can divide out of this, so the GCF is 1. When you're factoring, even though the GCF is 1 in this case, I'm still going to put plus 1. It's not, the inside isn't going to change, but I still need it to be the same. So my factored form of this polynomial would be 5 times k plus 7 and 2k plus 1. You are now going to have time to ask any questions you have and practice some more.